Hi everyone, so today we're going to be talking about direction fields and how we use those to obtain information about our differential equation. So today we're going to be using y prime equals y times y minus 1 times y minus 3 as our equation. And basically what a direction field is a graphical representation of the instantaneous slope, or our derivative, of a function at multiple points y. So here you can easily draw a direction field by using a table of values. So y and y prime, you plug in those y's to your equation and get your y prime. So I've already done one line. When y is 0, our slope is 0, so we draw horizontal lines. When y is -1, y prime is going to be -8, so we're going to have negative slopes. When y is 0.5, our slope is going to be almost 1, so like that. When y is 1, our slope is 0. And when y is 2, our slope is -2. So it's going to trend downwards. Cool. So that's kind of just an easy way to look at our slopes. And so now I'm going to show you what it looks like on a computer. Okay, so here we have the same slope fields, direction field, and we can look at where our critical solutions are when our slope is equal to 0. As I said before, one of them is going to be 0, and another one is going to be 1. The last one that I didn't talk about, or I didn't show, was when y is equal to 3, our slope also becomes 0. And so those are your equilibrium points, critical solutions, what have you, and they have categories of stability. And so what that is when our y values, when we have y values above and below those points, our slope is either going to trend towards or away these points. So with y equals 3, you can see that on both ends, it trends away from 3. So that's going to be an unstable solution. Same thing with 0. When our y is 0, our values, our slopes are trending away, and also that means it's unstable. With 1, however, they're actually trending towards, and so that is going to be our stable solution. We also have semi-stable solutions, and that is when some solutions, some values are moving away from the point and some are moving towards. So we don't have one in this graph, but that would kind of be a sort of representation of it. Okay, so now we're going to look at the actual graph of this derivative function, and we can actually tell a lot about the function using this graph, and we can use you can use this to draw a direction field instead of using a table of values. And so how to do that? Whenever you have a section of negative y values in this function, or negative values in this function, that is when your slope is going to be negative. So you would draw negative slope points for your direction field. Between 0 and 1, you can see we have positive values, and so that would be a positive slope. Here, a negative slope again, because we have negative values, and a positive slope from 3 to infinity. Okay, so now we are going to talk about the stability. We can also tell stability using this graph. And so again, using our positives and negatives, anytime it's negative, we're going to have an arrow pointing to our left. Anytime we have positive values, I'm pointing to the right. Your negative values, so it's pointing to the left, and positive values, so we are pointing to the right. Now, on either side of each critical point, you can see that you have 2 arrows. Both arrows are pointing towards 1, so that is a stable solution. On 0 and 3, both arrows are pointing away from each of them, so that would be unstable solution. Now, if you take a look on 3, if we had 2 arrows going like this, one going away from 3 and one going towards 3, this would be an example of our semi-stable solution. But again, we don't have one of those here. Okay, so finally, our sample solutions. These are actually going to be our sample solutions for this point. And so the limit behavior of each one, you can see for the bottom one, The limit is approaching negative infinity. Here we are approaching 1. Here we are approaching also 1. And up at the very top, it's approaching infinity as x approaches infinity, or in some cases, t. Cool. I think that's about it. I hope this was helpful in kind of describing what direction fields are and how to use them to look at our differential equations. Thanks so much.